All right. So now that we have our barricade with the corresponding positions and attack positions and all that, what we want to start working on is the logic that is going to pretty much be, well, more or less making the zombie pick a position. So I'm actually a little bit curious, size-wise. They are a little bit on the close side, so we'll probably have to disable collisions or just make it bigger. I was going off of the reference of this being the size, but I think that this barricade, yeah, it's wider. So we're likely going to have to extend the positions out that the zombies can go to, but I'm not too worried about that just yet. What I'm going to do in the meantime, let's go to our zombie pawn, go to our capsule, and it is blocking pawn, so we're just going to make it temporarily, not plugins. Ignore other zombies for testing's sake. And we're likely going to have to do this, I think, probably anyways, because otherwise it might get a little bit, well, crowded. So in our zombie pawn, let's set it to ignore pawns and accept. So now they should just ignore each other and ourselves. Well, our players, anyways. So to begin, we need to work on the AI logic to make it find a position to go to. So to do that, let's go to our AI, state tree, and open up our zombie AI, where we have this initial state of find and attack player. Now, I don't necessarily want to go into this state. I want to have another state that we use instead, and let's call it go to and attack barricade. Or we can even have it just where you go to the barricade once you claim a position, then you're starting another state tree and, a whole host of other things. But I want this to be before the find and attack player because I don't really want to go, down to this one, then to this one, so on and so forth. I want it to be straight into this one. So, which it will be because we're doing the children in order, or we could honestly just do a transition or force it into something if we wanted to. It doesn't really matter. So we'll end up here. And then based upon if this is successful, which will only return successful once we vault in to the play area, it will jump then to find an attack player. Otherwise, we're basically going to be just sitting in this state here, doing whatever we want it to do. So let's go ahead and we will, I guess, go ahead and duplicate our zombie AI and we'll name it to zombie. Let's do go to and attack barricade. So it's probably a wise idea to, split these up, but we're going to delete those two states and just start working. So the first thing we want to do is going to be a go to barricade. So we first off are going to basically, well, go to the barricade. So we need to find a barricade. Now to do that, we need a custom task. So let's make a new, I'll just duplicate this print string one, and let's call it find position in barricade. So this will be kind of like our initial, more or less, I guess you could say, go to, so to speak. And we're going to have some sort of event that is, you'll see as we get there. So we'll delete the string. We need to know about the pawn. So we can go ahead and add a variable called actor. We'll make it of type actor. And we'll set the category to context, so that way it's automatically filled out with this one here. And for us, for testing anyways, we're going to do a get all actors of class, and the class being the barricade. Then in our case, we're just going to do a get because we want the first index. And yeah, that's pretty much it. So from here, we need to basically find, or I guess you could say reserve, a slot for the zombie. So that's where we need to start working on the logic part. So let's go back to our barricade.h, have a U function, do blueprint callable, and category is barricade. And we'll just do, let's say, void claim slot. Or we could do claim position, doesn't really matter. And I'd kind of like to rename this to zombie slots instead, but I'm not too concerned. But we need to pass in the zombie that is claiming it. So a actor, zombie. And this needs to return a slot. So f vector as the slot. All right, so we want to iterate over the slots, or the zombie positions rather, and basically check. So if the zombie position dot value dot zombie is invalid, good grief, can I hit the arrow keys right? So if the zombie is invalid, meaning it's basically no zombie there, then we have a valid position. So we want to set the zombie position dot value dot zombie to equal the given zombie. Then we can simply return the key. So in our case, we actually probably want to output the vector and return true or false now that I'm thinking about it. So let's change that to a bool. And down here we return false. Here we want to return true. And we need to add a f vector by reference as the actual slot. So here we want to set the slot to equal the zombie position dot key. So let's go ahead and fix up the header like so. And there we go. So we are now, quote unquote, claiming a slot. Now what I want to do in addition in the tick is if a slot has been claimed, I want to set it to be a blue color. So let's go ahead and alter our color logic. So we're going to have the same thing there. But if the zombie position dot value dot zombie is valid, we want to set the color to equal f color blue. So we can watch them, be claimed in real time. So now that we have that, we need to restart the editor, recompile, and relaunch in order to get this set up and start testing. Okay, once we are back in the editor, go back to our task, and we want to go ahead and claim a slot. So the zombie is going to be the given actor, and we're going to do a branch. And pretty much, if it is false, we want to finish the task with false as whether or not it was succeeded. So here we can do things like kill the zombie, destroy it, do kind of whatever. But we mostly needed this slot. So let's go ahead and promote it to a variable. And yeah, I'm just going to literally call it slot, I guess. And set it. Then we want to put the category as output. So compile, save, and let's add that task. So we want the find position in barricade. And here we have the slot. So now once we find a position, we can simply do a move to. And for the target destination here, we can do the position in barricade slot. And that's going to basically move us to whatever slot we found. So now we just want to go ahead and as a test, go to our zombie AI, go to our go to and attack barricade, change it to a linked asset, so we can use the go to and attack barricade state tree. And this will go ahead and basically start running this logic we just made as a test. So now that we have that, let's go ahead and we need to go back to our AI, go to our zombie AI controller, and plug in the start logic. And with any luck, this will hopefully work. So let's really quick go ahead and visualize. That might be an issue. Let's go to our barricade and look for the can never affect navigation. Let's turn that off. And there we go. It's no longer going to be a problem. But we want to set it, closer to the ground where it would be. So once we have that, Go ahead and press play or simulate, and after 2 seconds, hopefully the zombie will at least start to move, which does not seem to be the case. So let's try some printing here. So let's do a print string after we claim a slot and print out the return value. Do it again, and we are getting true, so it's being spammed, which means we are not finishing the task, which is correct. We don't want to, because otherwise it's going to basically ignore this move too. However, we're having an issue here. So I'm wondering if it's due to it just being up too high for the given nav mesh for whatever reason. So I'm going to lower it down here and just see if that's the case, which it does not seem to be. Okay, so we are getting the slot that we need. We're setting the destination. We should be able to just move. So let's try out of I guess as a test, instead of starting the logic, we're going to do a move to some random location. We'll just do, I don't know, 0 and see. Yeah, and he's still not moving. So that makes me question if something else is wrong that I forgot to check. So let's go ahead and make sure it does have the right AI controller, which it does. It's that guy. So I am a little bit confused. So in the meantime, I'm going to go ahead and check and try to see, what all is going on. Okay, so I found the problem, and it was we are using the relative location. So we need to basically convert it to the world transform in order to actually, simply go to the right spot, because we're going to the relative location, and that's a no-no. So back here in our claim slot, we want to convert this to world space, and we can do that using this. So because we're using it in multiple spots, I'm going to go ahead and make a simple function that will just return a slot location. So let's do a let's do a f vector get slot location, and it'll be a f vector, or rather a const f vector slot, and let's change it get slot world location rather, and this will be a constant function. And in here, we're just going to take this, copy, paste, and we are going to return that result like so. So we're returning transform location, get active location for the transform, and slot for the location. So that way in here, we can go ahead and do a get slot world location, and we're going to pass in the zombie position dot key. Then we can remove that as well and call the same function here. So slot equals get slot world location, passing in again the key. So now that we have that, we can restart the editor, recompile, relaunch, and hopefully we are good to go. Okay, once we are back in the editor, go ahead and try it again. And there we go. So they're actually moving to a slot, I think. Make sure I undid the logic, which I did. So we are using it entirely off the state tree. So try it one more time. And there we go. We have our actual location. So 1640, 710, 50, which is different from that, which is our offset, I guess you could say, world position, which is, the one that is basically right here in the center. Okay, let's go ahead and close that, close our controller. Yeah. And we can close out the zombie pawn, remove our prints, and that there's at least good to go. Now I am curious why I'm not seeing the position change. So I'm wondering, maybe this is just modifying a copy. So if the zombie position is valid, which this should make it valid, one of these positions should go from red to blue, but it's not. So I'm guessing we are basically making a copy, and this is not actually modifying the real value. So let's swap this out. So T tuple, and it is that's nice, it auto fixed for me. And in our case, we want to do it by reference. Now let's go ahead and run our live coding, and this should allow us to go ahead and modify the original value rather than just making a copy and modifying said copy. So there we go, we claimed that middle position. So after 2 seconds, or 1 second, that position is claimed, and then it goes through and basically tries to find a different one to claim, which is obviously not correct, but that's just due to our state tree logic. So it's going and finding the next unclaimed, then because it's close enough, it's finding the next unclaimed, then the next one, then the next one, so on and so forth. Now, in our case, I'm going to drop the acceptable radius to 1. And after this completes, I'm just going to go ahead and add another state, which we'll just do a sibling state and call it chill. So in this one, we're going to simply add a delay task for, I don't know, 10 seconds. Nah, let's just do run forever. So when go to barricade has finished, so let's do on state complete. We're going to go to chill. So now should reach that slot and just, well, chill. So here we can see we need to make some bigger adjustments to move these slots over. So right now we're doing basically by 50. Let's try bumping that to 100. That might be a little much. 75. And I mean, that's pretty darn close. I think about 75 is going to be sufficient. So let's start modifying these over. So instead of 75, or instead of 50, we're doing 75. And then starting over here, we're going to do negative 100, then negative 50, then 50, and 100. So I want to change the negative 75s to 100, and the other 75 to 100, then negative 50, and 50. That should be quite a bit wider. Okay, I did something very dumb. That's pretty normal. So let's see. Oh, we still have some that are negative 75. Oh wait, no, those are right. Then we're offset. So we need this one to be negative 25, I think. Oops. All right, I'm doing something quite dumb here. So that needs to be farther over. So that was this one here. So if we're starting at 100, we need to be 75 away, which would be 25. Oh well, maybe it's just visually it's kind of starting to mess with me. So negative 25 plus 75, we get 50. Then we end up back at 100. Start at 100 again. Negative 25, 50. Okay, I'm being dumb again. All right, so that took a minute, but I realized what I was doing. Basically ended up just taking 75, which is the offset over here, and simply adding 75 divided by 2 to it, which ended up giving me this position, and then just moved them around. So that way everything is nice and symmetric, and we at least have a larger gap, grab the wrong thing, between the, well, various points. Now this is something we are likely going to have to tweak, but this should be roughly the distance between each zombie. So I'd say that's pretty decent. They're close, but not, too close in my opinion. Okay, so we have it where we can find a random point, claim it, and move to it. Let's give it another try with a few more of them. Let's try 4. Make it nice and simple. So we claimed all of those. 1, 2, 3, and 4. So he's having a hard time reaching it. And there he goes. So that's something we're going to have to resolve as well. And I'm not sure if that is collision or the RVO avoidance, because we're using zombie pawn. And I thought I said that to ignore, which I did. So let's see, we're using avoidance. Let's uncheck use RVO avoidance and see if that's what is causing it. So it's either that or just normal collision. Okay, so it was RVO avoidance, because now they should basically walk, I guess you could say more or less in it, so to speak. Or not in it, but inside of each other. Okay, so we have our points, everything is moving to it. And basically, if we have too many, which I think that is, okay, I need 2 more. Oh, wait, sorry, I need a couple more than 2 more. So that way we do have too many. They're just going to stand there because they have nothing to do. So they're not going to be able to claim any slot. But that is correct. We have our positions and all of that. So I am quite happy. We just remove some of these. And there is one other issue that I am looking at. So for example, let's say we have a zombie coming over here at this angle. Once the position has been claimed, it stops moving. It doesn't actually rotate the face the right direction, so we need to make the zombie turn, but that can be done later. So, with that out of the way, I will see you in the next video. If you like what I'm doing and you want to help support me, you can find a link to my Patreon in the description below, where you can also get early access to this entire series.